Mathematical notation is a language, and a very precise one at that. There may be many different ways to say something in English, but we aren't allowed that same degree of freedom when writing something in mathematical notation. Writing limit notation is a good example. Here's a limit statement that's in mathematical notation. We might interpret this in a lot of different ways in words. The limit as x approaches 2 of f of x is 3. As x approaches 2, f of x approaches 3. The y values on the graph of y equal f of x approach 3 as x approaches 2. Or even if it's clear what function we're talking about, we might say the limit as x approaches 2 is 3. And in an appropriate context, we may even be able to just say the limit is 3. But in mathematical notation, we are not given the same amount of leeway in terms of how we can write our mathematical statements. In terms of limit notation, we need the following parts in the correct places. What? The limit. Where? As x approaches 2. Whose limit? F of x. Get ready for it. Equals the answer. All of these elements need to be in there in the appropriate place. For one-sided limits, there is one more piece of information that we need. We have our what, the limit, where, in this case, x approaches 4, from which side, in this case, the negative sign says from the left. Whose limit are we talking about? Our function is x plus 1 over x minus 4. Get ready for it. Our equal sign goes there, right before the answer, which in this case is negative infinity. Let's practice this by writing limit statements for 6 indicated portions of this graph y equal f of x that is given here. Be careful to use correct limit notation. Pause the video while you write the limit statements. When you're done, resume the video so that you can check your answers. Are you ready for the answers? Here they are. Did you get the correct answers? Did you write correct limit statements?